Hi guys, welcome again to today's meetup and webinar conference. I have two fantastic guests today. I have Tamara Fischer, who joins us, and Hans Edert, both from SS. Hi, welcome. I think we will have a great session today. Just before we start, I would like to introduce you a little bit to what you can expect and what tools are available at your hands. So to make that more interactive, as you know, we are not broadcasting events. We live from just the interaction with each other. You can also ask the questions you have all the time. So if you look in the navigation bar, there's a section which is Q&A. So if you click on that, you can actually see that you can ask questions here. Feel free to ask your questions you have during the session. I will have a look at it. Neither Tamara nor Hans is expected to do that because it's my job. So I will take care that your questions will be answered either during the sessions or at the end. We will see what fits best. There's no question also just to be silly. So ask questions and don't fear anything. Nothing will happen. Just ask for things you want to get answered. Yeah, so thanks again for joining us. We will have our topic of today is ModelOps, whatever that means, but I think we're going to learn about that a little bit more. And in the driving seat of a model lifecycle, I love it, right? Driving seat is always cool stuff, right? It's no one who can just say something is happening with me, but I can steer and how to do it. I think this is a very curious thing, and I hope to get more insights here. Tamara, so welcome you, and can you tell us a little bit about you personally? What's your background?
Yeah, sure. Well, I am a statistician. I studied in Germany in a town called Dortmund, and I work for SAS Institute now for 23 years. And in this, with this background, I had several projects around the topic of analytic. But I started in the consulting group here or department where first of all, I learned how to prepare the data for analytics and work on the ETL part. And actually, I'm in the role of a so-called customer advisory or customer advisor, where I interact with our customer to help them find a good solution for their problem. So
Awesome.
this is my actual role.
Okay, cool. So you're helping to figure out what might be a solution to a problem of a client, right?
Yes, that's my role.
Okay, fantastic, Hans. And what's your work on a daily basis? What are you doing?
Yeah. Okay. So yeah, I when I started working, I was a software developer long ago. Yeah. So when we had these punch cards, no. Okay. that's not true. That's not true. But yeah, I started as a software developer. Then when I joined SAS, I started working in the pre-sales department in Germany, and nowadays I'm working on the regional level. I'm on EMEA. I'm taking care for EMEA customers, and I'm a software architect now, a solution architect. Yeah, so more the engineering guy.
Oh yeah, fantastic. Are you working both on different industries or focus on a specific industry?
So not me. Yeah, we are covering all industries.
Yes, in your team, okay. And Tamara, what about you?
Yes, we are specialized on different industries, and I'm in the insurance department.
Okay, that's fantastic. I mean, if anyone has more specific questions, now you know it. I'm looking, or I've started a poll in the meantime. You might have recognized that. I can see the results, the first results also. So one of the questions is, what is your profession? I think that's always helpful, a little bit to try to figure out how to focus your presentation on. In fact, we have 19% data scientists. So software engineers and architects together, 27%. So a lot from the coding side as well. We have 12% consultants, 17% business, which is also cool. So we have quite a good mix, and 9% others. Sorry that I didn't ask you better questions, so that you have been able to tell me a little bit more about you. I think the mix is quite good. We have a lot of tech, we have consultants business, so we have both sides nearly 50%, right? I also asked, what is your level of knowledge in the field of AI? Because now we can adjust a little bit how you can talk. So we have a lot of people who are just novice to the field, 50% basically, which is interesting. So advanced expert level is about, yeah, also 50%. We have even one guru here. That's fantastic. So hopefully we can talk more in details here. I just stop the poll at the moment. So since I think we have a lot of stuff to cover at the moment, and I'm really excited to learn more about ModelOps, I say take the floor. It's up to you.
Okay. Thank you.
Okay.
Tamara, yeah. Okay, great. So I think I see what you see, yeah, which is our title screen. So this is the fancy title of today, yeah. If you can just, or let me request
Yes.
control, yeah, so it's easier for me. Okay. Can I control your?
No.
Let me see. Yeah, this is working. Okay, cool. So I'm sorry for technical things. Yeah, we've already Ooh, it has stored my mouse clicks. But that's okay. Yeah, this is okay. Now, fine. I mean, we have already introduced ourselves a little bit. I'm Hans, Tamara. We will do a little bit of an role play today. Yeah, so we have lots of things to show live. But we also have some theoretical parts. I will start giving you a short introduction into the topic. In the demo, I will also cover more the, let's say, the engineering parts, the parts of an architect. Yeah, I'm not a data scientist, and the complicated stuff, the cool stuff, will be handled by Tamara then. And she's also then in a. So we have two parts of this demo. And she will talk about the statistics and the algorithms that we are going to use today. But we will also show you software in two different parts. But yes, I'm going to kick off, yeah, and then I will be silent. Okay, so today's topic is ModelOps, yeah, and so our goal, our idea was to first give you an idea of what we or how we understand that topic, that idea, that what are the key topics, the key characteristics of this, before we really show you some live examples, something how we imagine, how we think that you could do that in a real world scenario. Yeah. So on my first slide, what you can see here is actually something that we have stolen. Yeah, no, I mean, we have cited it. Huh? It's not stolen. This is a paper. It's a very interesting paper written by folks at Google. Yeah, you can see the title, and there's also the link on the bottom. I can recommend that you spend the time reading it because it's it's quite interesting. When we think or when we talk about analytics or how analytics can support us to enhance and to improve business decisions, and you know, this has been a topic that has become much more and more important in the last years. Usually we tend to focus only on the model development part. Yeah, and if you look closely and very, very, very closely at this picture, that's the small black thing in the middle. Yeah, so this is the model development part, and I mean, it's understandable because everybody loves to do that. Yeah, that's the fun part. Yeah, this is what Tamara likes to do. Yeah, but unfortunately, it's only a very small piece, and this is something that these authors, these folks that have written that paper at Google, this is what they have pointed out in this paper. Yeah. So if you take a step back and look at the whole picture, you are surprised to understand that model development is just this very small piece. And what you can see here, there are a lot of other topics that are, in the end, much more relevant or important to make your work actually successful, because your work actually needs to pay off in some respect. Yeah, so it's not having a good model, having a very accurate model is a nice thing. It's a fine thing, but in the end, you're writing your model for some purpose, yeah, for some business purpose. And until that model can realize that purpose, it's not, it doesn't pay off in the end. Yeah. So running a model, an analytical model in a real world, in a production environment, that comes with a lot of dependencies. Yeah, and you have to cover a lot of additional work like data preparation. You have a lot of operations topics. You have infrastructure topics. Yeah, and all of this needs to be covered. Yeah. And in this webinar, we actually want to focus on these topics. So we are not going to focus on this cool little black thing, yeah, but we are rather focusing on the larger boxes that you can see here. Yeah. Yeah. Okay. Okay. So in order to get yeah, to get closer to this topic, it might make sense to realize or to have a first picture, a first approach to understand how, what's the model, what's the life cycle of the work that you're doing? What's the model life cycle? Yeah, I think this diagram is quite common. You might have seen it in different variations. This is nothing that we have a copyright on. Yeah, this is, I think it's quite common sense. And just to explain it a little bit, you start reading it from the lower left. This is actually, and then you basically follow the stream, the line 8, and this is covering the different stages of your analytical model. You start with model development. You have to prepare your data. You have an hypothesis that you are following. Finally, you start coding. You generate your model. Now we are moving to the center of this picture. You're leaving the development phase, and then you're actually entering the phase of model deployment. Yeah, so you have to take your model and you have to put it into a different environment, usually at least. We call that sometimes. We call that publishing or deploying a model. Anyway, how you call it, it's always the same operation. And once the model is deployed, it actually starts living, right? It has not lived before. This is the moment when it really comes into life. And at that point, you need to start monitoring your model, because it's also, I think, common sense. Everybody knows that your model is not something that is stable and works forever. Yeah, it will degrade over time because your data changes, the situation, the business situation, yeah, changes. So you constantly have the need to monitor the performance of your model, and at some point it becomes worse and worse and worse. And so at some point you are back basically at square one, and then yeah, you have to redo this cycle. Yeah, so it's basically something that doesn't have an endpoint. Yeah. You might be surprised to see that right half of this picture. This is something that we at SAS like to add to this life cycle, because we think that a standalone model, usually does not fit the bill. Instead, you have to embed your model into a decisioning framework. Yeah, so the decisions, the outcomes of your model have to be used somehow. Yeah, so what we usually say is, if you have a business application that uses a model, then you have to apply rules, or you have to combine your model with a rule set that takes actions based on the outcomes of your model. Yeah, just think about an application form on a web page, for example. Yeah, you do not just want to return a code. Hey, we scored you with 0.8. Yeah, but you want to do an let's say an reaction. Yeah, you are going to offer something or not offer something. Yeah, as a result of that score. Yeah, this is a decisioning framework that we usually use at SAS. This is a little bit of our extra add-on, if you like. We are not going to cover that today, but it's part of your model lifecycle. So this is why we wanted to show it to you today. As I'm sorry, yeah, this one today. As I said, we are going to focus on the center pieces, yeah, not on the model development, not on the decisioning part. We are going to focus on the model deployment, model validation, monitoring, and yeah, on this centerpiece of this picture. Okay, now the most important thing that I think we have to cover, or we have to talk about, is automation. So automating analytics is key. Yeah, if we talk about ModelOps. Unfortunately, that means that we are going to take away a little bit of the fun. Yeah. So if you remember this little black box, so if we talk about automation, this is maybe not what is your primary concern as a data scientist, but it's actually the point where you have, well, you could say this is the point where economies of scale come into play. So instead of investing a huge amount of time for handcrafting a single model, it might be much more effective to automate or to industrialize the model development and the model deployment tasks as much as possible. So why should you manually optimize a model for a single product, sorry, if you could automatically manage the models for all the products in your portfolio at the same time? And also manually deploying models does not really scale if you have a high number of models. If you do that, it will quickly pile up a large amount of technical debt, and eventually you'll get buried under that pile. So you will not be able to have enough time for the fun part, for the model development part. You'll be completely covered by the tasks of keeping your existing models live, and alive. So what should you do instead? Instead you should actually aim for a factory approach to analytics. Now that sounds fancy, but what you also have to keep in mind is that this requires changes on many different levels. So if automation is actually a top priority for you, then your workflows have to change, and also your tooling needs to support that. So you need tools if you want to take this approach. So if we, I'm sorry, the mouse often jumps. So if we try to come to a definition of what we understand as, or how we understand ModelOps, I think there's three key points that we should mention. The first is ModelOps is about improving or streamlining or fastening, speeding up the process of bringing a model into production. And the key, as I said before, the key here is automation. If you do everything manually, you'll never be able to catch up speed. Second facet is, or second point, there is a cultural facet to ModelOps. Often we tend to think of ModelOps purely as technology and tools, but this is not true. And the reality is that any of these opsy things, let's take DevOps for example. This started actually out as a cultural shift, to streamline the communication between groups. In the case of DevOps, obviously between developers and operations people. And if your organization is not set up to support that idea, then your DevOps, ModelOps approach eventually will fail, actually. And for ModelOps in particular, this means that the traditional lines between let's say business and technology domains and teams, they need to be blurred or even taken down. So again, this is a very important topic in my point of view. There's a non-technical, there's a cultural aspect to ModelOps. And finally, as I mentioned before, ModelOps is actually a little bit of a misnomer, to some extent, because like I mentioned before, we very often see that a single model does not really fit the bill in a real world use case. Instead, we often see the need to add rules to your model so you can automatically take action on a model output. And that's what we call decisioning, as I mentioned at SAS. Okay. So you might think we start making advertisement for Google. Yeah, that's not true. But in fact, these folks have written yet another cool paper, which I also can recommend. They have lots of time to write papers.
We can hear that. Yes. So we have some Googlers in our community.
Oh, good. Yeah. So it's great that you have the time to write these papers. Yeah, I can recommend that one as well. Yeah, you can basically read it as a follow-up on the first one. Yeah. So this paper actually focuses on model testing as part of automating model development and model deployment. Yeah, so it describes a lot of more than 30 tests for all aspects of your machine learning framework. Yeah, so basically all these black boxes on the right half of the screen, these are areas where you can or where you should deploy tests, automated tests in your environment. Yeah, and this paper actually really supports also the case that we are trying to make here in our session today. So in the machine learning space, you should lean on standard processes that you have learned from software development. Yeah, like having unit tests, having integration tests. Yeah, this is well known, well established. So yes, definitely, yeah, keep to that, stick to that, apply that, but at the same time, you need to take into account that analytical models are fundamentally different. Yeah, in some respects. Yeah, because the behavior of your analytical models is so strongly depending on the data that they are working on. And you can't easily predict how changes in the data lead to changes in the performance of your model. Yeah, so this is a fundamental difference to software development. And that also means that your tests actually need to be more sophisticated. Yeah, so let's say if you have a simple unit test that is based on assertions of an expected outcome, yeah, of your model, that won't work. I mean, at least it won't work over a longer period of time. It might work when you develop the test, but it will soon fail. Yeah, because the data changed. So, and in our demo, we are actually going to focus on a few of these tests. We haven't deployed all 30, just a few of them. Tamara will explain some of them in more detail. And we're going to show you how to run or to have that, to have an automated pipeline that makes use of these tests. Some of them, yeah. Okay, I'm nearly done. This is basically the final picture that I wanted to show you. This is like a little explanation of the demo that we are going to show you today. This is, let's say, a typical workflow of a ModelOps environment. Yeah. So when you start looking at this in the upper right corner, yeah, in the upper right corner, you see, or you can see that we assume that there are two different user profiles. Yeah, we have the data scientists that love to work in coding environments, Jupyter notebooks, in RStudio, things like that. Yeah, they like coding. Yeah, and corporate IT might have prepared a data science workbench tool for these users. So, or you might even work on your local laptops, depending on your policies. But actually, you are working in a coding environment, and to make sure that you don't lose your work, you usually use a local Git repository to commit your changes, so that you have some place to save your work. Yeah. There might be a different class of data scientists that prefer using visual tools as well. Yeah. Sometimes we call them business analysts. Yeah. They also do analytical work, but they usually don't do coding. Yeah, they use a point-and-click interface. For this demo, we are going to focus on the coders. Yeah, because I think this is the more cheerful group. Huh? This is anyway. No, but yeah. So for this demo, we are going to assume that we have a typical data scientist loving to code. So at some point, the data scientist actually will want to register his or her work with a central model repository. Yeah, so let's say you are at the point where you say, I'm done, I'm good, the model works for me. Then actually you want to hand over that model because you're now en route to bringing it into production. So in this picture, in the center, as you can see, we have that model repository, and we are using a SaaS tool called Model Manager, and that's a front end for that repository. So for your data scientist, if you want to register your work, you're using a REST API call. Yeah. Now let's assume that we don't fully trust you, huh? I mean, you're nice, yeah, but you can't just check in anything into our central model repository, isn't it? We want to have we want to take a closer look at this before we actually accept it. Yeah, we have coding standards, we have quality standards, we have regulatory assumptions, yeah, rules that we have to follow. So we can't just take it, right? We have to check it first. And so what we want to do is we want to channel this process through a validation pipeline. And this should happen automatically. So this is actually the place, the situation, the moment where we apply the tests. So you commit your work, but before we accept it into our registry, we are going to check if your work is okay for us. Yeah, and if it's not okay, we are going to reject it, and you have to work on it again. You have to improve your work, and then you can try again. It's a cycle. Yeah. We are going to use a tool called Jenkins as our automation software. It's just a tool, huh? You can use whatever fits your policies. Okay, so I think this is the central part, yeah. But then we move on. Now the model is in the central model repository. We have accepted it, but it's not yet live. It's not yet published. It's not yet in production. So at that point, we are now in the center of the screen. At that point, someone will want to take over control and take care for these next steps. Yeah, sometimes we call this guy, this person, or this role, the model governor instead of the data scientist. Yeah, it's just a different role. It doesn't need to be a different person. Yeah. So usually you will have standard business processes in your company, which you have to take care for. Yeah, you might need a workflow tool. Yeah, we have a workflow tool in our software suite called Workflow Manager. But again, any workflow tool might just fit the bill. Yeah. So what are you going to do? The first task is you might want to take the model from the data scientist, and you want to take it maybe in a central Git repository. Yeah, that's one thing. From there, you could actually pull it out again, and then you deploy it in a validation, or let's say in a test in a test environment. Yeah, in a pre-live environment. That's at least usually a situation that we see with customers. Once your model has behaved well in that testing environment, we can finally, and now we are actually in the screen, we are now in the right half. We are now in the situation that we can say now, okay, we've quality tested your model. We've also tested it in a pre-live situation, and now we are finally able to deploy it into your real production environment. Yeah. We will show you a few ways of how to do that later. Yeah, you could imagine as, let's say, we're going to deploy it as a container, would be an example. We could deploy it into a database, would be another example. Depends on a lot of things. Yeah, it's different from between the industries. For each customer, it's different. Okay, now let's assume we've done that. So the model is in production, it's working, it's producing results. And as I said before, this is not the end. You remember, the life cycle is infinity. Huh? And so what happens now is we have to monitor this model. Yeah, so we have to check the results, and we have to make sure that the quality, the output, the level of the quality does not decrease. Yeah, we call that performance monitoring. This is something that you have to do on a regular basis, constantly. Yeah, and also that's the feedback loop, basically, that goes back from the right to the center. Yeah, and this process is something that you have, yeah, as I said, to do continuously, and at some point you have to react. Yeah, maybe you have an alert, you have something that triggers an action, and then you have to push back that work to the data scientist, and you have to explain your colleague that he has to start working again on your model. Yeah, because it has degraded over time, it has become worse, it needs to be retrained or even redeveloped. Okay, and today Tamara has the task of guiding you from the upper left to the right and back to the left. Okay, Tamara.
Yes. Thank you very much. So now, so first of all, we need a model. As Hans already said, we will not focus on how the model was created. I just show you my Jupyter notebook. I was using Python to create a model, and the business case here is that I would like to predict whether there will be a claim, yes or no. So it's a binary classification problem where I trained the model. On the left-hand side here, you can see the outline of my Jupyter notebook. So I did all the necessary steps, which are usually necessary to train a model. Yeah, you can see I read the data, I do some data preparation steps, I build the model, I assess the model, and yeah, then when I'm finished and I like the outcome of my model, what happens then? Yeah, and this is a step what we like to show it to you. And but first of all, one question: when we talked a lot about a model now, but what is a model? Yeah. And I think maybe it starts here that you have a clear understanding of what a model is. So is it just a pickle file in case of a Python model, or should we add something here, which is necessary if you would like to run your model into a productive environment? Yeah? Maybe you need to know, oh, well, my model needs some special input variables and my model creates some output variables. Which are they? So we call this metadata. And maybe we also need some information about the type of the model, which algorithm was used, who was a developer of this model. All these metadata information should be captured in a central model, so-called model repository. And to do so, we have written some functions here, or we used some open source from SAS, which is also available on GitHub, to create those metadata files around our model. Yeah? Not just the model file, the pickle file is captured into our central repository. We also save or store all the information around this model. So this is a step, what you can see here on the step 3, and I create some JSON files, which are capturing the information about my model as well. So I just go through these steps where I write the JSON file for input variables, the JSON file for output variables, some metadata information about my model, and some other properties as well. And of course, I will also store the information about the accuracy or the status of my model when I register my model. So the fit statistics, the ROC statistics, and the lift statistics are also written to the central model repository. This information can be used later on to compare as well models in the central repository. So this is a nice feature that you also store these information as well. So at the end, I create a zip file here of all my model information. And I'm done from here. Now we go to another Jupyter notebook where I just register, or I push my project or the zip file into Git repository. This is what I'm doing here. But there is one special thing here at this step. I trigger a Jenkins pipeline when I tag my work with a special tag, so that, as already mentioned from Hans, you have seen this little sign with a Jenkins validation pipeline. this pipeline will be triggered by the next step because of this tag. Yeah? So this is something special maybe when you push your project into a Git repository, but this is the way how we implemented this little piece of triggering the Jenkins pipeline, which will do the validation of my model automatically. Yeah? So now we should see something on the Jenkins pipeline in a few seconds. You can see it starts here. And now maybe Hans explains what's going on here in this validation pipeline.
Of course. So, yeah, so as you have seen, this is just an implementation detail, but we wanted to give the developer some control over the point in time when he is actually running through this pipeline. So we chose that he has to tag his work. Yeah, of course you could just use any push. Yeah, any commit could actually trigger your pipeline, possible as well. What you can see here is a validation pipeline. So once Jenkins and Git are connected with a webhook, they're integrated, and once there is an event, a trigger coming in, this pipeline will start running. And as you can see from the headings of this table, basically, these are the steps. And there are some, let's say, preparation and post steps. Yeah, but in the center, you see that we are running a couple of checks and tests. Yeah, there are some simple, let's say, unit tests. Yeah, for example, the score integration check would just see if all these metadata files are part of the zip. Yeah, so we check if the developer, he might have forgotten to include his score function into the zip file, and what should we do with this in our repository if he's missing, if we are missing the scoring function. So we are just doing some simple checks. We could do a lint on the code, yeah, to see if he has forgotten to put enough comments to it, yeah, whatever. Yeah, these are the simple checks. But we also have more valuable and more statistically interesting checks. Yeah, Tamara will cover them in a few minutes. But I think it's interesting to understand that we also try to predict the model quality at this point already, without actually having seen, without actually running the model. Yeah, this is quite a clever test. Yeah, Tamara will talk about this today. Or this run, what Tamara just did, this is green, which means that on the last item here, we are accepting this model for the model repository. So this is fine. We are taking it. Yeah. If you check down at the bottom here, you can see it start. There are two runs that are actually that they ended in red, and that is one of the checks failed. So we are not going to accept this version of the model. Yeah, so we run the checks, then we evaluate the results. If the results are bad, we are rejecting, we are breaking up here, and we are not accepting it. And one interesting challenge at that point for us was, now this is a tool that you as a data scientist would not actually use probably. Yeah, this is not really your day-to-day working environment. Yeah, Jenkins. So how can we make you aware of what we did? Yeah, so we have to find kind of a feedback, a mechanism for giving you feedback. And what we chose to do is we are basically just checking in the results of our tests into your project. Yeah, so Tamara, as data scientist, could Stefan?
Quick question, Hans and Tamara, because Olga asked, and I think it's a good point for that. She was asking, what tools do you use? I think we saw some things that you have Jupyter notebook coding.
Yeah.
Git, as you mentioned, for as code repository, right?
Exactly. Yeah.
Jenkins you use for the automation part, the validation part, and she also wanted to know, how do you monitor models' performance in production?
That. Give us a second.
Yes.
That's the second part of the demo. Yeah.
But maybe one remark here, we have two repositories here. we have one, the Git repository, yeah, to save our work. This is maybe you, as a developer of your model, you may work continuously on your model day by day. Yeah? But when you say, okay, I'm ready with my model now, I would like to do the final check-in, for example, then we are also, when this Jenkins pipeline runs, we are also registering the model into the SAS model repository. Yeah, this is the second repository, only in this case. So we are working with two types of repositories in our scenario here.
Yeah, one for codes and one for models. Yeah. Okay, now, and Tamara, you have already gone back to your working environment. And
Yes.
if you, I mean, I didn't point it out, but actually the run that failed was run number 94. Yeah, so we might want to check the results of that run.
Yeah, so we go into this folder here, and I get all the log files and output files from this program. And I will open now this PDF document for you. And we did one test which is called feature contribution index test. Yeah? And you see some graphics here in this test, and you see the deviation, yeah, of this feature contribution index of two different data sets. Yeah? The blue line could be on trained or no, applied on data where you trained your model, and the second one maybe is a data set which is already in production. Yeah? It's not a test or trained data set, it's the actual data. And when the difference of the feature contribution index between those two tables, the base table where you trained your model and the actual data is too big, then we reject your model, because you might have to go back and retrain your model on actual data. But there's a problem sometimes when you do such a test. And how are we evaluating models? Usually there is a need for the outcome variable, for the true outcome. And when we use a model into production, or when we bring a model into production, sometimes we don't know the true outcome. And this feature contribution index is able to work without the true outcome on the actual data. And I will explain this to you in a few slides. So here you can see my training or historical data. I have feature 1 to feature n. Yeah. And usually I need my outcome variable. In the case shown before, I had a classification problem, a binary target, claim yes or no. I do my training, I have my model, and then I deploy my model into production. But how can I assess the model performance when the true outcome is not available? Yeah? And this is where the feature contribution index comes into play. And I would like to explain it a little bit for you on the next slide. It doesn't work. I don't know why. So here, look at this small formula here. Yeah? The key idea is to compare the covariance structure of the two data sets, of the base data set or training data set and the actual data. Yeah? You take the predictors, not the outcome variable, only the features or predictors, and compare the structure. Instead of comparing the whole covariance matrix, you can also compare just the covariance of the predictor or feature and the prediction itself. Yeah, not the true outcome, but the prediction your model does. So you can just go down into each feature, and then you get for each feature this feature contribution index. And here are two pictures on this slide as well. On the left-hand side, you can see what happens if from time to time you have a data shift just in the mean of your features. And you can see this red dotted line here, which is a confidence band, and shows you that you are in between this confidence band. When only you have a shift in the mean. But if you have a shift in the correlation between your predictor and your predictions, then it can easily happen that you go out of this band here. And then when you have this red circle here, that you go out of the confidence band for the feature contribution index, then our test will fail. And this was happening in the build of 94 here. So I would like to suggest another test for fairness, or so-called responsible AI. Often we have the problem that you make a mistake with the selection of your training data, that you have some variables in there which shouldn't be used, or that you select your data samples not in a way that your model makes a fair prediction. And here is one test you can do, which is really easily implemented. You just compare the conditional probabilities between your or one control group and the group you would like to protect. And if the this marginal, so-called marginal effect is too big, then you would also reject the model for those special variables. If you are interested in ways how to test, especially for fairness, then I would also recommend you one paper, which is also in our slides here for reading. Yes. So I think there was a question about the model monitoring part as well. So thank you for this question. You can see here what can happen, for example, when your data shift over time. And on the left-hand side, you can see the predictions you made for red stars and green stars. And on the right-hand side here, you see the true labels. And you can see that over time, the match is not very good, because I have a data shift in my data. And it's necessary that you have always a look at your model from time to time, especially on a regular basis, for example, per month, per week, per day. How frequently depends on how your data is changing. So you have really to test before you bring your model into production, or you have to have a feeling how often you need to monitor your data, and what, and to react on this at the end. I would like to introduce you as Model Manager as a tool which really cares for monitoring models here. And we are differentiating between two situations. The one situation is that the true outcome or label is available or not available. And we support some characteristic reports for the predictors. We have a stability report for the prediction itself. And of course, the feature contribution index report is available as well for model monitoring, not only for the test we did before we bring our model into production, but also over time when we get new data and we measure the model performance. And of course, there are other model monitoring reports available as well if the true outcome is available at some point of time. You will get the feedback how your customer reacted on special things, or if a customer churned, or if there is a claim, yes or no. So if this true outcome is available, then you have other metrics here to assess your model performance. Yeah, like lift, Gini, rock, KS statistic, or for in case of an interval target, you have the average square error as well available within Model Manager. So now we return to the software again, and I think we have one more slide here, which I think Hans would like to explain
right.
to you again.
Yeah, so just that you don't get lost, huh? Just before before we start with the second part of the demo, which actually focuses on this performance topic. Tamara is going to push this Python model. Yeah, now that we accepted it, she's going to push it into production. But what does that actually mean? Huh? This term, push into production, what does it mean? It could mean a lot of things. Huh? It could be a database, a Hadoop cluster. It could be a cloud service. It could be a container. It could be a Kubernetes cluster. As I said before, it can be very different. It depends on your industry, your company, your infrastructure, anything. At SAS, we like to use a component which we call micro analytic service, or MAS for short. Yeah, MAS is a program execution service. That's the most simple explanation or description I can give, and you can just imagine it as being kind of a wrapper. Yeah, so if you look at this picture here, you can see 3 of these MAS pods. MAS is a Kubernetes container, a pod. And the model that Tamara has developed, in her case, it was a Python model. This is injected. This is part of one of these MAS containers. And the advantage of doing that is that MAS, as the wrapper, as the shell, gives us a standardized REST API for communicating with this model. Yeah, so this is nothing that you have to take care for as a data scientist. Or MAS, the service, takes care for that. Also, we have standardized interfaces for monitoring, performance monitoring. Yeah, stuff that makes this pod, this service, part of our platform, basically. Yeah, so it has some advantages in terms of integration. Let's put it this way. We also support the other options like databases, Hadoop, and stuff like that. And we can also, of course, just deploy this Python model into a runtime container that has just Python in it. Yeah. So this is something that that you can do it as well. Why not? But if you do that, then it's your task to take care for the interface. Yeah. I mean, you have to have some way to talk to your model. Yeah. It doesn't. Yeah, you need it. you need an option to communicate with your model. We use MAS, and this is what Tamara is going to do now.
Yeah. Okay, so I have some problems to find my. So now I think we talked too much because now I have to re-enter my environment. I just returned to my now you can see SAS Model Manager the first time. I will just explain a little bit before I go to the point of our model. In this web application, I would say, yeah, you can see here the whole analytical lifecycle. So we support with us the whole analytical lifecycle with visual front ends. You can start with manage your data, prepare your data, explore and visualize. Yeah, this is one very important step as well in the process of model development. You can build your model with a visual front end as well instead of coding everything. I think Hans mentioned it in this in the overview slide that we have different types of data scientists. Maybe one who would like to code and another one would like to use a visual front end. And then comes a step here which is called manage models. And this is where we are here now in this screen. And as already mentioned as well, when you go further from here, you can also create decisions, where you can combine different models with business rules, for example, to find a final decision at the end, and so on. So what you can see here is the project view. So we have already some projects created in this environment. You can see this claim policy project. Another one is just called claims. We have a computer vision project here, as customer segmentation. One is called email classification. And here with this donut chart, you see the different projects per function. Yeah? As already mentioned, we had a classification problem. So we have this classification function, but you can also have a just unsupervised model here, like a clustering algorithm. Yeah, this is also possible. So we support different types of model functions here. And this donut here on the right-hand side with the yellow and the blue parts, it just shows you how many models here were already published into a productive environment. Yeah, and these are just two possibilities here. You can see one is called CAS batch for CAS scoring or serving. And another one is called mass local. And this mass local is the one we were using, or we will use with our model that we just registered to this environment here. So now let's go into the project where our model was registered to. So you can see here on this models tab that there are already 3 different models. Yeah. This is just because I run some tests before this event, but the latest one was just registered today in the evening here. So the Jenkins pipeline registered your model automatically because our feature contribution index test was successfully. So now let's look into the model and all the different assets which were registered here. So what you can see here is something which is called the scoring function. Yeah? And you can see that I'm using some packages here, and I have one function defined to score on new data. And you can also see some other resources of this model, yeah, as already mentioned. Yeah, you can see the pickle file, you can see the input and output variables and rock and lift statistics and so on. You can also take a look at your variables from this variables tab. Yeah, you can see variables which are used by my model, and you can see some metadata information around my model. What type of model do I have? Which Python, which scorecode type do I have? And you can see there are many different scorecode types available within SAS Model Manager, which are supported here. So let's close this here. And the next step, I would like to really do the publishing or deployment step for you. So I just check this last model and I will click on the publish button. Now, this is a little wizard where I can define a new name, for example, new GB claim. And in this dialog, I can choose between different so-called destinations or publishing destinations. Let's call it productive environments. Yeah? And now I take this one, the microanalytics service, which is able to run a model in a web application, for example. So the real-time context here. So I click on publish. And if it's successful, we can also look at a small application we developed for you as well. So I just have to go here to the model scoring part. So this is just for demonstration. Yeah, let's think about it like just a web application which is using my model in production now. So I just have to enter the name of my server where the model runs, and then I can choose one of my models, yeah, which were just registered into this productive environment. And I choose the new GB claim model here, and I can enter some values for my model to run this model. Submit it and wait a few seconds, because the first time it has to initialize a little bit, and then I get the result returned. So I get a result code here, and I get a decision classification 1, because there was a threshold in my code which defined that I would like a decision to 1. This will be a candidate for claim. And I also know the true probability for claim here. So this is our model which now runs in production. But over time, what happens with my model and what happens with the data in my model? And now I would like to return to Model Manager and give a small overview explanation of what Model Manager can do as well. So as already mentioned, we have this different projects. Yeah? Each project is one use case. You can also search within this interface for special projects, for example. And you have also a different view. Yeah? You have just a view on all of your models which are in this repository, and you get some information about your models. For example, the different model scorecode types. Yeah, we have a data step, SAS data step, or Python, R here already. And you can also see some model attributes here, and you can also search here for different models who have the same target variable, for example, to make a comparison. So I will search for a target variable which is called bad. And I can see, okay, I have some variables here already, models which have all the same target variables. So you can, from here, you can also compare your models if you like. Just click on the different models, and then you can compare it regarding the assessment statistics. So now I return to the claim policy project. I had to prepare this for you, the part of the, no, not this one, the claims project. I've prepared the model monitoring part for you because we just deployed our model into production, but there's another similar model running in production for, let's say, for 1 year now, and we would like to see the model performance of this model over time. And you can see I have this as well, the same model here, and we have the variables tab of this model, the properties. I can do some scoring tests here, which is, I think, as well, something like an integration test for my model. And I have this performance tab, and on this tab, I can run or schedule a job which regularly creates some performance statistics on my data. So you can see the different statistics here, for example, the KS statistic and the lift statistic, and maybe there's a small problem with my customized charts here. It says cannot access a report. It was created by a new version. Well, I think you have the option that you can bring in here your own reports. Yeah? So you don't need to use the reports which are available by the software. So I think I will. I'm sorry that I can't show it to you right now, but believe me, it works usually. I think it's something happened in the meantime. So I don't know what's going on here, but you can bring those reports in here, your own reports with your own statistics. And I had one report here, which was about the feature contribution index, yeah, where you can also see how your index is developing over time. And I just added a confidence band to this report so that you can see this report. So I think this is what I would like to show you within Model Manager, except one piece. I think we mentioned it. We have a workflow component which comes with SAS Model Manager. And this workflow component allows you to embed everything into your enterprise, yeah? Because usually not only one person is involved in along the whole process. So maybe someone has to approve something, or and you can really embed those tasks or the different tasks along the analytical model lifecycle with this workflow component. And I would like to show you how this can look like. You can see that I already created one instance of a model lifecycle. And here you can see that I'm just here at the step where I import a model. Yeah? We did that for the claims policy project as well. And then there are different tasks defined by someone who is responsible for those workflows. So this is a governance aspect of your model. Yeah, you can, when you are working with a workflow component here, then you can always tell if someone asks who did what along the whole analytical life cycle. And another aspect is here the automation aspect. Yeah, you can run from here every REST call you would like to run. Yeah? You can also run from here another Jenkins pipeline, yeah? Because we added here the capability to run jobs from here. So this is really gives you a huge flexibility to fulfill the requirements along the whole analytical life cycle. I think this is a key part of the ModelOps definition, that you can bring in here those aspects and how and especially you can customize this in a way you need it in your company. Yeah. And you can link those different workflows or life cycles to each project in Model Manager. Yeah, from here. So this is the last tab here. You can see that I have linked this model lifecycle, which was defined before, to my project. And then everything which is done on your project is tracked by this model lifecycle. So I think I'm at the end of our presentation. Maybe one last word. What happens with your model if it decreases over time? Yeah, you get alerted that something is not in between different thresholds. Then you can retrain your model or redevelop your model. You can go on, or you can also retire. This is what is on this last slide. Yeah. So to wrap up, what have you seen from us here? You have seen a full containerized workspace for data scientists. We were using isolated Docker containers. For model development, you could use SAS or Python. You've seen how to create such an automated model validation pipeline with Jenkins and which tests are possible. And I think there's a really huge variety of possible tests which could be added here. You have just seen one test here, but I believe that when we get more and more artificial intelligence into our world, that these requirements are really needed in a way of thinking about ModelOps, not just DevOps, or ModelOps is not just DevOps or the DevOps parts of it. It's much more analytic to make sure that you have a really good model in production. You have seen that we offer with us a central model repository, which enables you to keep track of model versions. You can, of course, trigger model retraining from there as well. And you have seen different model performance dashboard capabilities as well. So thank you very much for your attention. And now I think
assuming that we have left you with some time, huh? we would be happy to take questions, huh?
Yes.
Yeah, I would like to speak to the question.
I just allowed Simon Center to speak up and to ask his question directly. So Simon, welcome and thanks for the question.
Yeah, thank you for having me, and thank you for the great talk. It was very interesting to see how you manage models in production and what kind of systems you have there. My question is in regards to canary rollouts. So usually when we have a model running in production and we have a new one, we want to first see how my new model is doing in production, also in comparison to the other one. So how would you do such a canary rollout and collect the metrics for the rolled out models?
Well, we have also implemented the challenger concept, champion challenger concept. And you can, for example, first compare the one which is in production with the new model, for example, directly in the model manager environment, assuming that you are using the same data to compare your model. Yeah? When you have brought your model to production, it's in the repository of Model Manager, and you bring in the new model, the new version, then you can always compare those two models with respect to their assessment statistics.
I mean, that was the sophisticated answer. Yeah? The simple answer would have been, I mean, you didn't see that, but the whole environment, everything that you saw was running on Kubernetes. Yeah, that was a deployment, a fully containerized deployment. And you just can defer that task to the Kubernetes level, right? So you can use things like Istio, for example. Yeah, that's, of course, that's the technical answer. Yeah, Tamara's answer is better.
No.
Is that okay as an answer?
Yes, that does answer my question.
Okay, good.
Thank you very much.
Yeah, thank you as well. Thank you for all the questions. The good thing is, both of you, I can tell you, you basically answered questions during the presentations. So that was awesome. So I just saw the questions coming in. It was just like you're answering it without knowing it. So it looks like you perfectly addressed the typical questions. I would like to give you a little bit feedback from what I can read here. Zineb, thank you. That was very informative. Olga said, thank you, very interesting presentation. I think Simon also said great talk. So, hey, it was fantastic to have you here this evening. I think also it was a fantastic presentation, quite insightful, also to see the automation part of model building and model maintenance basically as well. So this was fantastic. I can thank you for both of you for showing up this evening. I know during Corona time, it's not that easy as Tamara has to travel back and it's getting late and there's some kind of closing time outside. So I hope you will make it without police interruption. Thanks again also for everyone who just showed up this evening. Thank you for being part of it and for making it just a fun to manage it and to watch and observe it. Last words here now. Yes, the session has been recorded, and we're going to process the recording. I think it will be available in maybe 30-40 minutes within the next 2 days, and it will be uploaded to the YouTube channel of AISWIS together. And that was one of the questions as well regarding the slides. Yes, the slides will be available once the video is up. You will be informed via meetup.com. I'm going to send out a newsletter for everyone who has been participating. You will also get a kind of link because we are partner of Deep Learning AI. And so there are some special surprises maybe for one or another who would like to roll up in one of the courses. And we want to get some feedback on how you actually found the evening and what was it like for you. So if you give some feedback, that would be nice for us as well. It helps us to improve everything, and it's also kind of a nice gesture to those who have been presenting. Yeah, more good news here. Terry, Mark, Miranda, everyone's just happy as it looks like. So I close it with a happy face as well. And I wish you all a good evening and come back home well, or if it's stay, have a nice day, whatever time it is. Thank you again.
Stay healthy, everyone.
Thank you.
Stay healthy. Bye.
Bye-bye.
Bye.